All right, guys. So chapter 2, we're going to get into routing and switching. We're going to talk about basic switch configuration, and we'll talk a little bit about switch security. Uh, this is also a point that I want to remind you all that if you haven't done so, download and install Packet Tracer on your computer. Not only is it really good practice just to play around with, but you're going to see some of the quizzes that you'll take with the Cisco curriculum are going to require that you have Packet Tracer on your machine. And I'll give you just a brief rundown. I know you're all familiar with it, but Packet Tracer is a program Cisco puts out that allows you to design a network virtually and connect to switches and routers and all kinds of devices as if they were physical devices. When you connect to them in Packet Tracer and go into it, oh, look, I'm being told here even the pretest required Packet Tracer. Very good. So if you don't have it, you need to install it tonight before you do the pretest. And it's in Blackboard for y'all, so you can get on there and get it and take a look at it. But it will allow you to design very complex networks. And between you and I, the way you're going to pass the Cisco CCNA is going on there and building a network and playing around with the settings and changing things and seeing what happens. And the best way you can do that is Packet Tracer. While we do have a limited number of switches and routers in the lab that you can go physically play on, the beauty of Packet Tracer is it's a program you can load on your machine, and you can do this at 3 in the morning if you want to. You can play around with it, and because it's a file, the other cool thing is if you have a problem with it, you can upload it and I can take a look at it, or we as a class can all load it and take a look at it and see if we can figure out what's different about it. So in this chapter, we're going to talk about the advantages and disadvantages of routing. We're going to talk about the initial settings needed on a Cisco switch, how to get into it. We're going to talk about switch ports. We'll talk about the management of the switch virtual interface. We'll talk about basic security attacks in a switched environment and some best practices. One big thing here is putting some passwords on your switches because they're wide open physically if you don't. And if I'm an adversary and I'm trying to get into your network, if you don't put passwords on these things, if I get physical access to these switches, I can get into your network pretty quickly. That's especially important in some of these places like college campuses, especially the older ones. I pick on LSUS because I'm most familiar with that network, but in a lot of those buildings, they were built before networks were that big. We had nowhere to put the switching equipment when we brought networks into the buildings. And because of that, in a lot of the buildings, it's in the back of janitor closets that remain open a lot during the day. So if somebody wanted to break into that network, if we didn't have passwords on everything, they could wait for the janitor to get their mop bucket full of water or something and go somewhere, sneak in there and plug a computer in and gain access to our network that way. And we also talk about port security. And there's goods and bads to that. We'll discuss them. So much like a machine, when you turn on a switch, you go through a power on self-test. And this is a post just like a computer does. Before we post, we're going to check the memory. It's going to check that its processor is running. It will run a test on the ports. Once we've done that, we load the bootloader. This bootloader is very much like your master boot record on a computer. The bootloader is going to tell it how to load everything else. The bootloader will perform a low-level CPU initialization. And then it initializes the flash file system. And flash is where we actually have our Cisco iOS stored. Now the bootloader loads the default iOS operating system image into memory and passes control of the switch over to the iOS. Cisco has called their operating system iOS for a very long time. And this gets into a very interesting, we could have a whole nother class on capital I, capital O, capital S, which is Cisco, and lowercase I, capital O, capital S, which is the operating system that Apple puts on iPhones and iPads. But since this is a Cisco class, you can just assume anywhere you see iOS, we're going to talk about Cisco here. So to find a suitable iOS image, the switch goes through the following steps. First, it's going to attempt to automatically boot using the information in the boot environment variable. If that variable is not set, the switch performs a top to bottom search through the flash file system. It loads and executes the first executable that it finds if it can. Now that's important because you may have more than one executable on your flash. So it's going to load the first one unless you set that boot environment. The iOS is then going to initialize the interfaces on the iOS, and it's going to go into its configuration and load the startup config. The startup config is stored in NVRAM. And we have different configs we're going to talk about in a minute to make sure you understand. But the boot system command can be used to set the boot environment variable. One reason, and I'm assuming the slides are going to get into this, but one reason that's important is when they update Cisco iOS, maybe I want to, if I have a big enough flash, chances are very high I'm going to want to leave the old flash on my, the old iOS on my flash card and load the new one as a separate file. Well, based on how they're stored on that file system, it's going to load the first executable, which may be the old one. So I may load this new iOS on there and it's never going to touch it. But if I set the boot system variable, I can tell it load the new one. From a standpoint of network admin, it's great because I can say load the new one, but if it totally crashes, I can break the config as it boots up and go back and change that boot system to the old one, reboot it again, and my system comes back up. Now I've still got some troubleshooting to do. Obviously something's not right if I can't load the new one, but my network's not going to stay down while I'm doing that. I can then go to a test environment and play around with it and see if I can figure it out. Here's another place that I'll tout the use of the packet tracer software so much. I can actually load one of my config files into packet tracer and play around with changing things in it and maybe figure out what command is breaking the boot sequence or what command is not working and change it there. So switches, as I've said, are basically like computers, and they're prone to crash. What I have always told my classes is the best and the worst thing about Cisco. No matter what you're doing, a Cisco switch does exactly what you tell it to do, even if that's the wrong thing. You can make these things do things they're not intended to do, and they will crash themselves if you do it. So if you crash the bootloader, what you can do is connect to it with a console connection. And a console connection, remember, is where we're going to connect to a serial cable. We're going to put a serial cable on the console port on our switch and actually run it to our computer. This is why in the first Cisco class I talk about finding a laptop with a serial port on it being next to impossible. But for $8 or $9 you can go on the internet and buy one of those USB to serial ports. I keep one in my laptop bag at all times specifically to work with switches, because if the things crash down, the only way I'm going to get into it is going to be to connect to that console. So once I've unplugged it, I plug it back in and hold down the mode button while I'm doing it. The system LED will turn amber and then a solid green release. When I release, I'm going to get a solid green light. Once I get that, I'm going to get a switch colon prompt. And at this point, I can actually issue commands to the switch. This is also something pretty similar to the way you're going to recover a password if you lose your physical password to your switch. So with most Cisco devices, specifically we talk a lot about the Catalyst here because that's one of their largest lines. Each of the ports on a switch are going to have LED indicator lights. And based on the color and the status of that light, you can learn from just looking at it what the ports are doing. You can also learn what speed the ports are connected at. On the gigabit switches, for example, if they're connected at 100 megs, they're going to be one color, and if they're connected at a gigabit, they'll be a different color. So on the 2960, which is one of the pretty common Cisco switches, you've got a system LED. You've got a redundant power system LED, which will let you know that both power supplies in the device, if it has two, are working. Each port's going to have a port status, a duplex, and a speed. And then if it's a power over Ethernet enabled switch, then you'll have a PoE mode LED light. So here we're looking at just the switches on the side of a typical Cisco. System LEDs at the top, an RPS, a status, a duplex, speed, and then PoE at the bottom. So in dealing with switches, something you're going to learn as you get more into this is that if you're the net admin for a medium to a small, or even I'm going to say a small large company like a college campus, you don't really do a lot with Cisco switches. Once you get them set up, you kind of leave them alone. But one of the beauties is that you can remotely manage these if they're configured to access the network. And the way you do that is you give each switch an IP address just like it's a computer. When you're managing these, you also have to set a default gateway just like you do on a computer so that you can access it from wherever. And some things you're going to have to set in IP are going to be the address, the subnet mask, and the gateway. Although these IP settings allow remote management and remote access to the switch, they do not allow the switch to route layer 3 packets. That is important because something you learn about switching, generally when we talk about just saying a switch, we're talking about a layer 2 switch. We're dealing with MAC addresses. However, it gets really tricky because especially Cisco switches are capable of layer 3 switching, which means they act as routers. They can be configured to act as routers. But by default, just giving an IP address to a switch does not mean that you're allowing that switch to route layer 3 packets. They won't do layer 3 routing until you tell them to do layer 3 routing. So here we're going to look at just some basic iOS commands on a switch. So if you remember these from Cisco 1, the first thing you need to do when you're logged into your switch is type config or configure terminal. Once you do that, you're going to get into the config mode, and then you're going to set the interface for the virtual management. That by default is VLAN 99. So I'm going to type interface VLAN 99. I'm going to configure the management IP address by typing IP space address space and a number. Now they don't show it here, but you'd also need to set the gateway and the subnet mask. If you wanted to be able to access it from other networks outside of this 172.17.99 network. We also have to enable the management interface. Now remember, Cisco makes everything difficult. To enable an interface to stay up, you have to issue a no shutdown command. So I'm telling it, don't shut this port down. Once I've issued a no shutdown, I'm done in my config if, so I can type end. And then finally, I have to save my changes. Remember in Cisco, this is a pretty common command. Copy your running config to your startup config. If you don't type that last command, what's going to happen is when you reboot it, we're going to move the, we're going to lose our changes. They're not going to be there for us. All right, here we're going to set a default gateway. We're going to config terminal again. We could have done this earlier while we were there, but they're just showing you individually how to do each. IP space default dash gateway, and then our gateway address. Notice they missed a .1 on this. This should be 172.17.99.1. If you issue it without a .1, I believe it'll kick back an error. Now I need to dig. Maybe Cisco realizes .1 as a default, but I'm not sure. So I will try this command and tell y'all. I don't think it'll work. I think it'll get an error. I'm going to leave my config if with end, and then I'm going to copy the running config to the startup again. All right, so when we're configuring switch ports, we have the ability to use half duplex communication. Half duplex is where basically we're going to act like a CB, if you will. I'm going to send or receive, but not both at the same time. However, with switches, and one of the great things about them is that they can handle full duplex communication. You can send and receive data at exactly the same time, and the switch is able to handle that. So generally, you're going to leave this set at full duplex unless you happen to have some very old device on your network that can't receive and send data at the same time. Then you can issue this, this command to make that single port half duplex. So here we're looking at configuring switch ports at a physical layer. So here our first command, again, we're looking at switch 1 is going to be our conft, our configure terminal. Now I'm saying conft, remember, because, and I'll try to not do this very often, but the more y'all do this, you'll learn some of these little shortcuts. You don't have to actually type out configure space terminal. You can type conf space T and hit enter, and that is the same command. Almost every command in Cisco has a shortcut command, and it just makes it a little bit quicker if you know those commands. You can copy space run space start as another one to copy your running config to your start config. So once we do a conft, we're going to get our config. We're going to say we want to configure an interface. So we're going to type interface space fast Ethernet 0-1. That is our 0 is our first switch, port 1. You would only use 1-1 if you had switches that were hooked together. We'll talk about those later. They're going to issue the duplex full command. They're going to then say speed 100 and then end, and they're copying the running config to the startup config. So another thing that we talk about in Cisco is what's called MDIX. And this is not just Cisco. Most switches now can handle MDIX. And what this is that if you think back to where you talked about wiring, you have some ports or some places that use the 568A type of wiring and some places that use 568B type of wiring. And those were just differences that were created way back when we started wiring up buildings. The way that you connected two switches together or two hubs together was to make a special type of cable called a crossover cable. And this crossover cable was wired as A on one side and B on the other side. And once that cable crossed the data over, basically all the crossover did was change the transmit and the receive wires, so that transmit on one end was receive on the other and vice versa. This also came into play back when you didn't use all 8 wires in the 4-pair wire that we connect to Ethernet. In the old days with category 3 cable, for example, when everything was running at 10 megabits, we only used cables 1 and 2 and 3 and 6. So that meant 4 of the cables in that piece of wire were not used. And that became important because you already had that wire running to an office. Earlier I talked about needing to run a separate wire for telephones before convergence. Well, what you could actually do is run, since telephone only needs 2 wires, you would run 2 phone lines on that same piece of cable that you'd already ran. And since it was different wires, you didn't get a lot of crosstalk because of the wires that were chosen. But so the MDIX feature basically just allows the port to automatically determine what type of wire it is and if its connection is to a computer or to another switch. And it makes the port crossover automatically if it's needed. Almost every switch, managed or unmanaged, is going to do that now. So if you get if you get just even a little home switch and you set it up, chances are you're not going to have to deal with that. But know that this is called MDIX, and it should be set to auto. And unless you change it, it will be set to auto. But here we're going to see that to make sure that it's set that way, we can do a configure terminal. We can interface fast Ethernet 0, 1. Note here that they did not put capitals in fast Ethernet this time. And I want you to see that because you can do it either way. And I don't want to lie, but I believe the shortcut is FE. So I think I can do an INT space FE0-1 to get the fast Ethernet port 1. My next line now shows me that I'm in the config interface mode. Duplex space auto will set the duplex to auto. Speed space auto will set that speed to auto as well. And then MDIX auto sets that to automatically determine if we need crossover. I'll then end and I'll copy the run to the start so that it'll boot up with that the next time. Now once we've done this, we can do a show controllers Ethernet controller fast interface 0, 1 and include auto MDIX, and this is going to show me that auto MDIX is on for that particular port. So some other commands that you can do, show interfaces space and the interface ID, if you add that, will show specifically the information about the interface that you're looking at on the switch. Show start or show startup -config is going to show what's stored in NVRAM when you reboot. Show run is going to show the config file you've got set up right now. And one thing that is important to understand about this show run and show start, it shows the data in actual Cisco commands. And the reason that's important is I'm a bit old school, but something that I've always done when I work with a switch is once it's set up and properly configured the way I want it, I'll do a show start or a show run if they're the same. And I will, using whatever terminal software I have, I will capture the output. And I will then go into Notepad. It's going to pause after every screen. And I'll take the line out with more on it where it paused. And what that gives me when it's done is actually a file with all the Cisco commands that were issued to that particular switch. Having that stored as a text file on my computer means later I can telnet or SSH or I can plug a console cable in. And if this switch completely bites the dust and I have to get a new one, if I get the same type switch, no problem. Plug that switch in and I've got this config file right here. I can copy that config file and play it using any sort of software that will play the file back, which any of your terminal programs like PuTTY, or if you're using Windows, even Hyperterm will do this. I can play that back and it will issue those commands to the switch. Once I've issued all those commands, then all I've got to do is a copy run space start to save it. And once I've saved it, then I've completely rebuilt that switch from the file I had. You'll notice that if you're dealing with a large network, unless you're doing something specific on the ports, most of these config files are going to be the same. So by keeping a copy of that on your machine, if you get a call as a NetAdmin and they tell you, hey, the switch in building E went out, assuming you've got a spare switch, all you got to do is go plug that sucker in, plug it in and set it up. It'd take you maybe 5 minutes to get a new switch running. So here we're looking at how to address some of the network layer issues. And here we see we're going to do show interface fast Ethernet 0, 1. It tells me that that Ethernet interface is up. I'm being given the address I'm using, the MTU. Then we took some of the output out just because we don't need it. But you see it shows me how many packets have been sent, bytes and received. 0 runts, 0 giants, and 0 throttles. Remember, a runt from Cisco 1, a runt is a package that's too small, and a giant is a packet that's too big. I know that there was some error if a runt or a giant got through. Based on what type of forwarding I'm using, those may never get through, though. I have 3 input errors, and they're by CRC here. If I go on down, I have 8 input errors. I have some collisions that have happened here, and late collisions at that, and those are the lines that are highlighted here. Seeing those collisions tells me that there's probably a hub hooked to this thing. So here, just what I exactly said. A runt is a package that's smaller than the minimum size. In Ethernet, that means anything smaller than 64 bytes is a runt. We don't allow data using the Ethernet standard of anything that's smaller than 64 bytes. On the other end of the spectrum, anything larger than 1518 is considered a giant. Now, it's important to distinguish a giant from a jumbo because jumbo in dealing with wireless is a little bit different, and we allow jumbo packets if we've configured our wireless to allow that. And the reason for that is wireless and Ethernet are almost identical, but because this data has to be sent and then an acknowledgement sent and receipt of the acknowledgement sent back and the packet torn down and all of these things, we sometimes do these jumbos on our wireless, and that takes several packets and puts into one and sends them at one time, and then receives back an OK for all of those. But on a wired network, those should never be seen, because once that jumbo packet gets back to your access point, it's going to break that into individual packets before it puts it back out on the Ethernet network. CRC errors, again, are generated from the calculated checksum not being the same as it started. And then an output error is the sum of all errors that prevented the final transmission of datagrams. Collisions are where we had an actual collision on the Ethernet. And then a late collision is a jam signal. And the reason that it's specified late collision is because that could be some other sort of interference that didn't allow the data to get through. It's not common, but some things that do interfere is if the wire was run over the top of some fluorescent lights, or if you've got someone that's got a very high-powered CB that's booting that thing up and keying up close to your wire. All of those are things that can jam your signal, and they will cause the late collisions. So in thinking about troubleshooting a switch issue, here is a little flow chart they give you on how to do it. First, they say perform a show interface. If the interface is not up, then you need to check your cables. Check and verify that there's no cable damage. Verify that the speed is set right on both ends. If the interface does show up, then you might need to see if there's noise. If there's noise, do your best to remove the source. Verify the duplex setting is proper. If the interface is up, some devices will not operate at half and some will not operate at full. Though almost everything is full now, there's still some exceptions, so make sure that it works out for you. If that solved the problem, then great. If it didn't, then document it and escalate the issue is their answer at this point. All right, so we talk about managing a switch with a connection to a console, but another way we can do that is with Telnet and SSH. In general, I will say that I think you should turn Telnet off on a switch as one of the first things you do. And the reason for that is that Telnet data is insecure. There is no security around Telnet data. It is transmitted in what's called in the clear. That means if somebody is watching your network because they know how to watch it, and they are capturing data, and you Telnet into a switch and type your password, they're going to get your password. If you're using SSH, all they're going to see is the key exchange, and it's going to be harder for them to get the data. If they don't have the right pieces of the key, in fact, they won't be able to get the data. So Cisco has started supporting SSH for that reason. A version of the Cisco software, including the cryptographic features, is required to enable SSH on a Catalyst. Anything new that you see is going to have SSH, and I seriously doubt you'll ever deal with a version of iOS that doesn't. But if you find one that doesn't, you can update it to include it. SSH uses TCP and port 22, where Telnet uses TCP port 23. Notice either of these are using a TCP connection, which immediately tells you that's why you have to assign your switch an IP address to be able to get to it. So here they're using a very common program to access a switch called PuTTY. I use PuTTY all the time. If you do a Google for PUTTY, you'll find a copy of it. It's actually from a site in England. A guy wrote it, I believe, while he was in school. But it's a very nice standard SSH client. If you have taken or ever do take the Linux class with me, you're going to see a whole lot of PuTTY, because PuTTY is also used to SSH into a Linux box. So here, when we log in, we're going to use admin. Then we're going to type our password. Notice when we type our password with an SSH connection, nothing shows up, no stars or anything. That is a very typical Linux Unix way of password protection. And the reason for that is because it becomes insanely easier to break a password if you know how many characters it is. Windows does that to make it easier on the user. It shows a dot or a star when you type a password so that you know you hit a key. But Linux and Unix do not do that. And Cisco's iOS is built off of BSD, which is a variant of Unix from the old days. So this is something that has stuck around. And the reason, again, is so if I'm shoulder surfing, I don't know how many characters your password is. If I see you type it and I know it's exactly 8 characters, then I can go home and running a cracker through just trying to try passwords. I've eliminated a whole lot of things because I know your password's exactly 8 characters. So by not showing it, we are able to get rid of that. Notice you still also have an enable password to get into the config admin interface. And 2 other things I want to point out here for y'all to remember from Cisco 1. Notice my prompt changes from a greater than sign to a less than sign to a number or pound sign when I type my enable password. So to configure SSH, we have to generate our keys. And to do that, we're going to type configure terminal. We're going to give it an IP domain name. We're going to then do a crypto key generate RSA command. This will say enter the name for the keys, which here we're going to call it s1.cisco.com. It asks us how many bits for the password. 512 is the default, but you'll notice here they changed it to 1024. So we're generating a stronger password here with a 1024-bit key. You could do 2048 here if you wanted to. Larger keys just mean a little more overhead and a little slower in connectivity. So then we're going to do username admin. We're going to set the password to CCNA. We're going to then configure the virtual terminal 015, transport input SSH, and then login local. That then turns on SSH for that device. Then we're going to end, and what they're not showing here, your next command would be to copy your run to your start to make it permanent. So when I do show IP SSH, I can see that it is enabled. By default, I have 90 seconds to type in the password when I connect. I have 2 retries, so if I type the password wrong, I have 2 tries. And then it actually shows me the RSA keys. And the reason you want to see those keys is that we won't get into it here, but further down, it is possible with SSH to save your login information in an encrypted key that's stored in PuTTY locally and stored in Cisco iOS remotely, so that you from your particular computer don't have to type that password when you SSH from one machine to another. This again is layover from the old days of early BSD and Unix, in that you can build scripts to have computers connect to other computers automatically. The best example I have to give you of where this comes in to be useful is for those of you that have been out there or know that it exists, I have a lab out at Barksdale. And that lab is part of our BIPSI lab. We teach some classes out there. Well, I have a server out there that I want to be a mirror image of the server that's in the lab in 315. And since we don't have a lot of money, I'm doing it over the internet using SSH and using a program called rsync. And rsync basically just synchronizes the file systems every night. So what I have is the system at Barksdale has a script that I built on it to SSH into the computer at the lab, which has a public IP address. And the credentials are stored on there in a user that has access to the file system. So when that script SSHs into that computer, it's connected and it can see both file systems. From seeing both those file systems, then I run my sync command. And once I run the sync command, I am able to, and my mom's calling, hang on y'all. Once I see the sync command, I am able to, or the script automatically syncs them up and just does the changes from one to the other. And that's done with what's called a delta copy. That keeps it from copying the same stuff if it's already there. And really the only thing I truly sync, even though I'm doing some other files, the big part is the Microsoft MSDN share, which has a copy of everything Microsoft has got that's part of our free access through on the hub. So when I add a new thing to it on the main campus that night, I know it's going to copy those files over to Barksdale. And I want them out there mainly so we have access to them, but it also gives me a bit of a backup because should something happen and the lab at Bixby or the lab at Barksdale one burn down, I have all that data in another place. All right, so there are some security concerns when you start dealing with local area networks. And one of those is in what is called a MAC address flood. And this is where you mess with the CAM table by sending data that keeps the switch from ever being able to figure out where to send data. A couple of ways to do this are by using a MAC flooding tool that just basically creates fake data and sends it out using MAC addresses that don't really exist, or using the broadcast FFFF. By sending this data just backwards and forwards, you are in some cases able to flood the switch, because anytime a switch doesn't know where to send data, it sends it to all ports. The reason for that again is to guarantee delivery of the data. So when these frames reach the switch with the bogus MAC address, it just sends it to everyone. Then you change that MAC address by 1 and send it again. Eventually you will fill the table with bogus MAC addresses. Once the table has no room for more devices, it never finds the addresses on the table, and then all frames are forwarded to all ports, which allows the attacker to access the traffic going to the other ports. So this is an old type of attack called a flood. Here they're just showing an example of creating these floods. You use software that creates random MAC address files, or frames rather, and sends them out to every, to the switch just as fast as it can. Pardon me. Once the switch is full with all of these fake MAC frames, then it just starts sending the data everywhere because it doesn't know what to do. And we don't talk about it here, but there's a way to protect us from that by setting a way that frames, or that our CAM table updates itself. Another one is DHCP spoofing. And two of these, DHCP spoofing and DHCP starvation. Now think back, DHCP, our Dynamic Host Configuration Protocol, is the way that our clients are going to get IP addresses on our network. And in these attacks, what we do is, with a spoofing attack, we put a fake DHCP server on the network, and we let it assign addresses to the clients. A DHCP starvation is often used before a spoofing attack to deny service to the legitimate DHCP server. So here we're looking at this. An attacker activates a DHCP server on a network segment. The client broadcasts a request for DHCP config info. The rogue server responds before the legitimate server can respond, assigning the attacker an IP address from the pool on the rogue server. The host packets are redirected to the attacker's address as it emulates a default gateway for the other DHCP server. So in this example, with client over here, client's going to hit this server first. And in a good DHCP spoof attack, this server is going to act as a gateway and send the data on out to the legitimate server and the legitimate internet or wherever it's going, so that the client doesn't know they've connected to anything fake. Their data is just maybe a tiny bit slower, but the average user is not going to notice that. But this rogue DHCP server can then just make sure and make copies of all that data, store it to go over later to figure out what they want to about that client. So Cisco uses something called a discovery protocol. And this is a layer 2 proprietary protocol for Cisco called CDP. CDP is designed to allow the devices to auto-configure their connections. If an attacker is listening for CDP messages, it could learn important information about the device model and the running software version. Cisco recommends disabling CDP when it's not in use. Some places use it, some don't. To be honest, it is somewhat of a security concern, but it also helps you to know what's going on your network. It's kind of completely up to your admin as to whether they'll disable this or not. Now here we talk about Telnet, and I talked about this earlier about why I don't like Telnet. Telnet can be used as parts of other attacks, but mainly because I can see your password. I turn Telnet off on everything by default, and I would suggest you do the same. So here we're talking about, with Telnet, a denial of service attack. And that is a flaw in Telnet server software that renders Telnet unavailable. Basically, we hit Telnet with just as many fake passwords as we possibly can, and we flood the system. And if Telnet's the only thing you have on the switch, and I do a denial of service attack on it, you can't get into that switch either because your legitimate Telnet connection's not going to get a chance to make. So that keeps an administrator from remotely being able to manage a switch. That can be combined with other attacks as part of a coordinated attempt to prevent the administrator from accessing core devices during a breach. If I'm gonna try to break into a system and they have Telnet on, I'm gonna figure out a way to break in. But when I get in, I'm gonna do a Telnet attack as soon as I get into that system, because that way I can try to stop the admin from seeing that I'm in there doing anything, and maybe I'll have enough time to copy whatever file or do whatever it is I want to do. So this is also an area where we talk about best practices in security. And suggestions they have, I kind of agree with a lot of these, no matter whether you're big or small. Develop a written security policy for your organization. Make a list of what you're going to do if a break happens, who you're going to contact, and who's going to deal with it and how they're going to deal with it. Shut down unused services. Telnet's a good example. You don't need it for some specific reason, shut it down. Use strong passwords and change them often. This is the hardest one for an admin, but it's one that you really should try to do. And I'll be the first one to tell you I'm guilty of not doing it at times. You should not use the same password. For example, thinking about the switches that we have over at LSUS. In a more secure network, what we really should do, there are roughly, I'm going to guess, maybe 150 switches over there on that network. Every one of those switches should have a separate IP address that's not the same. A separate password that's not the same. Now, in truth, do they? No. We have one password that's a master that will access all of those switches. We did it for ease of handling because there are only 2 people that know it. But still, that is a security issue. We should not have the same password for each one. Control physical access to the device. That is very important and something that gets left out of most security plans. I tell people this with servers too. If I need access to your server because I want data off of it, and I can't get into it remotely, but you leave your server room open and there's no cameras, I'll try to get somebody to steal it. Why worry about trying to hack into it if I can physically steal it? Use HTTPS instead of HTTP. Same thing here about Telnet. We want to use things that are more secure when we're able to. Um, Perform backup operations on a regular basis. As a net admin, I can't tell you how important that is. Make sure you back up your data. Make sure you test that your backups work. The one time your backup won't work will be when something fails and you need it. One of the things that I would do every week over at LSUS is just randomly take one of my backup files and log into something. And I would just connect up and connect to my backup tape and pull just a file off of one to make sure it worked. If you employ online backup, still do that. Check it. Try to download a file, make sure it works. You want to make sure your backup works when you need it. Another key part they put on here that I think gets overlooked is educate your employees about social engineering attacks. I use this in almost every class that I talk about security in. I generally don't think people are not security minded. I generally think people are truly ignorant about how to be security minded. And the example I use with that is people know to lock their door when they leave their house. They know that leaving a door open is just inviting someone to come in. Is that going to stop somebody from really getting in? Maybe not, but you know what? It's going to stop some people. If I walk up to your door and it's locked, that's at least one way that you're protecting yourself. And when it comes to electronics, I truly don't think people know how to electronically lock their stuff. And that's why you have so many instances of things like open wireless networks that people don't understand, or passwords that are written down on paper. So if you have a good security plan, make sure everyone in your organization understands that security plan. Everybody from the janitor to the secretary, everyone in the organization needs to know the policy and needs to know to follow it. An example, social engineering happens a lot. If I want to break into your system, maybe I'm going to dress as a telephone service person and I'm going to walk up to your front desk employee and I'm going to say, hey, I'm from AT&T. I got a call that you need this telephone fixed and the block that I need to get to is in your server room. 9 times out of 10, if you haven't educated your receptionist on social engineering and on what to do in those cases, she's just going to let me in because I look like I belong there. A great one that I love to tell was in one of my CISSP classes, and I learned that a group that worked for a military base dressed up as exterminators, and they got through the front gate and they got into the server room of a classified network dressed as exterminators before anyone asked for their ID because they looked the part. They even went so far, luckily they worked for the military, but this was to point out a huge issue with military systems. These folks even went and got the little pumps that the exterminators use and filled them with water. So they were spraying water around on the floors as they were going. They looked the part and nobody questioned them. It's important that you tell people don't do that. Make a chain of command that they must follow and get upper management involved in that there needs to be very critical and harsh punishment for those that don't follow whatever chain you've set in your security policy. Even to the point of termination if necessary. Because if somebody gets physical access to your server and there's truly mission critical data on there, or maybe you've got trade secrets on there, you could lose your entire livelihood because a receptionist let somebody in that she shouldn't have. A simple policy here can solve this too. Don't let anyone in that room ever until you talk to me on the phone by person, or whatever the case may be, some sort of system like that. Another important thing is to implement a firewall. This goes exactly with number 2 on this list, shut down unused ports and services. put a firewall in there, and you'll see this as we get more into firewalls. I don't know if it's in this class or in 3, but with Cisco and with others, you have these things on a firewall called an access control list or an ACL. Your default ACL should basically be deny everything from everywhere all the time, which means you've completely locked up your firewall. Then you go back and issue commands one by one that are numbered before that deny all command to open only the exact ports you need open, only allowing the exact data you need through your firewall. And the reason for that is because that keeps things that you don't know about. Maybe some user has installed some software, and you don't know it, but if they don't have access to that firewall, that's going to stop it. Another security practice is keep your software up to date. This is important with Windows. It's important with Cisco iOS as well. When a new version of iOS comes out, you should look at how you're going to roll that out and roll that out to all your devices. Cisco generally has a master iOS now. It's basically the same executable that runs on all their switches and firewalls and everything else. But you want to keep that up to date. If your devices have enough room on the NVRAM cards that you've put in them, you can keep a couple of copies of the software on there. Something I would do as an admin is keep old copies of that all the time. All my cards had enough room. I would update one and make sure that it ran before I updated the other ones. And I would leave the old one on there for even 3 or 4 months. In most cases, to be honest, on switches, I would leave the old one till a new one came out. So there were 2 copies on there all the time. Then when the newest one came out and I didn't have room, I'd delete the oldest one and put the newest one on there, then run it. Then change my boot environment variable just to make sure that it's using only the new one. So there are lots of security tools that are available for admins. And some of these are freeware you can get off the internet. Some cost money, but it's good to look at some of these and figure out if your system is actually as secure as you think it is. If the money is available, I would strongly suggest you contact a professional firm that does what's called pen testing or penetration testing. And these are companies that you pay to try to break into your system. And the reason that becomes such an important thing is because they are an extra set of eyes that can look at a system you've built and figure out if there are any holes in your system before an attacker actually connects up to your system and exploits that hole. Most of these network pen test people will sign confidentiality agreements with you, which means that they agree not to disclose anything that they're able to get off your system. After they run through your system, they'll give you a report of all the problems that your system had. And you can take all of those problems and start closing them up to make sure that there's not any holes in your system. Now, even if you don't have enough money, something you can do is get a friend of yours, an admin that you know and trust, have them try to break into your system. Again, any chance you can get a separate set of eyes other than your own to look at your system is great. And it's just like coding. If you're coding a program and you've got an error and you can't find it, the more you look at it, the harder it gets. You let somebody else look at it, and chances are they may see the one thing you're missing. A good freeware program that you can do a lot of this stuff with used to be called Backtrack, but now it's called Kali Linux. If y'all have not looked at it, do a web search for Kali, and you'll find a copy of it. It's easy to download. And it actually runs as a live CD, so you can download Kali and burn it and boot it up on your laptop, and there's all kinds of different tests you can run with Kali Linux to look at some of the holes you might have in your system. All right, so the process of actually using these tools on a network to determine any issues with it is called auditing. And auditing the network is exactly like it sounds. It's like a financial audit. You're just going through and looking at things to make sure everything is done the way it should be. Good audits are going to include physical and logical audits. By that I mean a good part of an audit is to go through and make sure your users don't have their password written down on something. Monitor your network as an admin and you can see things that are out of the ordinary. There's software you can run on a larger network to point out things that aren't the way they should be. Two types of those are called IDS and IPS systems. IDS is an intrusion detection system, and that's done by determining a baseline of your network. And when something's a little weird, what an IDS does is alert you. An IPS takes that a bit further and not only alerts you, but then shuts down activity until you fix it. The idea there being that it's better no data get out other than bad data get out. Some places don't use IPS systems though because they actually do shut it down. If you're a big online bank, for example, you have to decide as an admin, or actually your upper management has to decide, is it better that we shut down our website if we think there's an issue, or do we leave it up and just alert someone that there's an issue? And different people will do that different ways based on whether they have an admin there all the time or not. So you can use these network security tools to do your penetration testing. They will find the weaknesses for you before someone else does. But you have to be careful because some of these tests can damage your network. Make sure you do have backups of everything. If you're going to run some tests against your switches, you might crash a switch. Make sure you've got a copy of your running config so you can fix it. They say an offline test bed is idea, and it truly is. The best thing is always to do a non-production environment. Sometimes you can't do that. If you have limited resources, you may only be able to do your pen test on your live network. I would definitely suggest it be done at an off hours kind of time. For the pen tests I did on the network at the juvenile court, for example, I did almost all of them at about 9 o'clock at night, which was, a little bit later than I wanted to work, but I wouldn't come in until 4 or 5 that day that I would do those, every 6 months or so. And I knew if I completely shut things down at that point, nothing was going to be, mission critical. The only thing that I would shut down is the program called JCATS, which is what they use to book juveniles into the system. But I'd call over to the juvenile jail, which was part of the court there, and say, hey, I'm going to run a test. If this shuts you guys down, I'll have you back up in a little while. And with it being at night like that, there were few people coming in, so they knew ahead of time they could just write them down. So here we're showing a very easy security guideline. Shut down the ports not in use. This is, it's pretty simple, but I want to give the other side of this. I'm shutting down all these ports that aren't in use. That means if they're wired into an office that's not in use, that port's not usable. However, anytime anybody moves into that office, they're going to have to call me as the admin to turn that port on. Now, why is that important, you might ask? Well, if I'm the only admin, I'm the only person that can do all of these things. If it's a medium to small business, you will learn if you become a net admin for one of these, your job title is pretty much electronics everything, whether you want it to be or not. At the juvenile court, I had this great title. I was CIO of the juvenile court, but I was the only one in the department, so I was CIO of myself. Being their net admin made me their security guy. It made me the I broke a printer, I don't know what to do guy. One day I was we messed something up on the machine that locks the jail cells and they're all open. What can we do kind of guy. So this is one more thing that you have to deal with if you're already busy. It's something else that's on your list of things you have to do. The plus to doing it is it adds security. The minus is it's one more thing you may have to do is to go on and turn these ports on. So here is another type of attack, DHCP snooping. And this specifies what ports can respond to DHCP requests. And this is a cool thing because this keeps you from being able to do one of the fake DHCP servers we talked about earlier. Because you say DHCP is only going to be responded to by this particular port on this switch. So by turning this on, you make sure that only that one switch can reply, or only that one port on a switch can reply to DHCP. Plus to this, it adds security. Minus to this, if you move DHCP servers to another server, you got to go in and remember to change this. The reason a lot of these things become important is they're just things you have to remember to do when something happens. DHCP moving it to another server, something that may rarely happen, so it's something you may forget that you set up. You've got to become, for a good admin, you got to make sure you make logs of this stuff so you remember to do it if something comes up. So then we get to something called port security. And this is an area that I both love and hate, and I'll tell you why. With port security, what you're doing is saying that only certain MAC addresses are allowed on a port. Anytime anything else tries to connect to that port, it gets denied. It usually will make a security violation report that either shuts the port down or emails somebody or something like that. The problem with these is that if you have users that move around or that maybe have a laptop and sometimes plug their laptop into the port in their office, if you set port security, every time they do that, it's going to generate one of these deny log errors, and then you're going to have to go on and figure out what to do about it. You'll have to go on and you'll have to change those, or you'll have to go on and add those. Another problem with this type of security is that one of the easiest attacks on one of these networks is a MAC spoof attack. With Windows, it's a couple of commands in software, but in Linux or Unix, there is one line of code needed to change the MAC address. They use port security at BIPSI, and it aggravated me because I often connect more than one computer in my office to the network. So I spoofed the MAC address of my computer that's actually in my office and put it on a switch. And that switch is now in my office connected up, and I can connect as many computers as I want to that switch. I probably shouldn't be telling y'all this, but y'all signed the agreement, so we'll just go with it. The reason I did that is specifically so I can plug in things when I'm in my office. But by spoofing that MAC, they don't know that I have more than one machine in there. And it's unfortunately very easy to do. So we talked about port security. The iOS considers it a security violation when either of these two is met. The maximum number of secure MACs for that interface has been added, or an address learned or configured on the secure interface is seen on another interface. Now you can set these different ways. Again, like I said at BIPSI, they have it where only one MAC address per port. So one address in the CAM is all that's allowed per interface. A better way to do this, in my opinion, as ease of management, there again being the key. BIPSI's system is more secure because they do this, but it's more of a nightmare to manage because they do that. So a better way to do it is say only a certain number of MAC addresses can be seen on each port. That keeps you from being able to flood the device, but it still allows users to move them around without it becoming an issue for you. The second one here, an address learned or configured on one secure interface is seen on another. That's one that I personally, if I were running the network at BIPSI, would leave off, because now with that on, anytime two users in a, say two faculty members in the same office trade places, one's going to sit by the window and the other's going to sit at the other area. Well, they move their computers, they can't plug them in without calling computing services. It's just one more thing that they have to do. Now again, computing services does this because it adds control, and I totally understand why they do it. I just personally would not do it because it's extra things that I have to do on top of all the other things I have to already do on the campus. And the actions, again, to protect or restrict or shut down the port altogether. BIPSI's idea is to shut down the port. That way, if you do it, you have to call them before you can undo it. So here we've got port security. By default, it's disabled. The violation is a shutdown, and sticky address learning is disabled. So here we're going to get in to set it. We're going to do our interface fast Ethernet 018, switch port mode access, and then switch port security. Here you're seeing we set the maximum to 50. This will allow 50 addresses on the port. And they've enabled sticky learning in this case. So here when I do a show port security interface for fast Ethernet that we just set 019, you can see the things we have set. And here we can just verify it by doing a show run. Now one thing I want to get you in the habit of, and it took me a while when I first started doing Cisco things, notice how a MAC address is addressed in Cisco. Instead of 2 numbers and a colon, Cisco looks at MAC addresses as 4 places and a period. So that is just it's just their way of doing it. It's just something to get used to if you're old school like me and you're used to looking at MAC addresses as number colon number colon. So here we're doing a show port security, and it shows me what the port security is set on the various devices. So a violation can put a switch in an error disabled state. The error disabled is effectively shut down. The switch communicates these events through console messages. There is software you can set to gather those console messages and give you alerts based off of them. If you've got more than a few switches, that's something you'll probably have on your network. And this software runs on one of your servers and gathers this data. From that, you determine what to do with it. By that, what I mean is that you may have it send you a page or an email or, text your phone, any of those things. Here we're looking at that the port is in an error disabled state. And you'll notice here status ERR disabled tells me that that port, fast Ethernet 018, has had an error. So here we've got we're showing fast Ethernet 018, and we see here that the link 5 changed is telling me that interface 018 was changed to administratively down. So turning it back on, I'm going to have to no shutdown. No shutdown will bring it back up. All right, another protocol that's pretty common on network is the network time protocol. And NTP is used to make sure that all the clocks are the same. The reason for this, if we get into Windows, is that Active Directory needs it. You need the time set the same on Active Directory for all the Active Directory computers to synchronize. There are reasons that you need that on switches as well, and we'll talk more about those later, but basically we can use our NTP to set the clocks to be the same. And generally, as long as you set from one source, all your clocks on all your devices are going to be the same. In my network at Bipsy, for example, one of my servers runs as an NTP server, and it gets the clock from time.nist.gov. And by getting that data from one place, it's set on that one server. Then that one server will synchronize that data out to the other servers. And those other servers will synchronize it to the client. And any devices that are set to pull it from that one time source will be able to get it. Here we're just seeing NTP client and server. You can run a switch as an NTP server. It's one additional thing that you can put on a switch. I generally don't do this, again, because I have a server do it, but if I didn't have a server in a network that did it, I could do it with my switch. And here we're seeing our NTP associations. This is going to tell us how often it's polling the clock and how it's changing it. So based off of the time, it will adjust it as needed to make sure that you have the exact time. Notice here we see that the drift on this clock is 0 point, a bunch of zeros, 91 system second. And that is kind of a rundown on Chapter 2. We talked about the boot sequence, LED modes, how to manage Cisco remotely. We talked about some of the security. This is a pretty busy chapter. So I think you may want to go back and kind of review these slides a little bit and play around with some of these commands you saw. Build you a little packet tracer network, just put one switch in it and issue some of these commands to see how they're done.